So was that
We are going to do advanced level question 6, but before that we are going to just do two questions, quick revision for his partner. And also something that is quite useful. Right, there are two ways in which you can, there's many ways, but here I said make x the subject of the formula. Eventually ending up you getting the solution to the quadratic equation formula. So I'm going to do these two things together, so you can see what I do there, right? So the first thing that we're going to do is we are going to divide throughout by a. So there's another way you can, I could first have moved that c, the constant term. So that means I'm going to divide 2x squared divided by 2 plus 7 divided by 2 minus 15 divided by 2 equals to 0. The idea is to solve the equation. The idea is to solve it, and the solution to the equation comes from this formula. That is also known as the quadratic equation formula. Right. Obviously here the a's will cancel, am I right? You'll be left with x squared plus b over a x. Right. I will go ahead and I will just move that because of space, yeah? Minus c over a. Are you with me? So this is the same, x squared plus 7/2 of x is equal to, in this particular case, 15/2 positive. Then you introduce side work. Don't try to do all of that work here and here. So we always find half of the b value, right? And we square. What is our b value? It's b upon a. So I'm going to find half of that and I'm going to square that. So inside I'm going to be left with b upon 2a. So before I square that, and I'm going to do the same here, you're going to find half of the value of b and you're going to square that. Our b value is 7 upon 2. You find half of that. Dividing by 2 is the same as multiplying by half. So sometimes this number is just a whole number that 2 can go into. Then you will see the people putting that 2 under that number. But since it's a fraction, keep it as a fraction, then you just use multiply by half. Alright? As opposed to divide by 2. But it's the same thing. So this gives you 7/4 here. Are you with me? So I've left it now in the same place as it is because this is what's going to come inside my bracket when I complete the square. That means on this side, I'm going to have x plus b upon 2a all square equals to. That is going to be there. So here I'm going to have x plus 7 upon 4 all square equals to. That is going to be there. Whatever you square becomes positive. Hence, you are told, add this number to the number that you have on this side. So you're going to add that number there. This 14 over 16 is in here when you multiply by binomial. So I'm going to add the same. 15 upon 2. My bad. So I'm going to do the same here. But we like the constant term or the positive term to be in front. So the square of this is going to be b squared over what? 4a squared. b squared, 2 squared, a squared. You get it? So that means I'm going to add b squared over 4a squared to this number. It's just that it's minus 1 writing on that side. I'm nearly done here because the only thing that I need to do is I need to take the square root. On the left side, I have two terms which I want to write as one term. That would be the same what I will do here with the number. I would want to write this. Of course, you can get this on your calculator, no problem. You understand what I mean? But if you do this, you will use the lowest common multiple of 2 and 16 is 16. 2 times 8 gives you that. And 8 times 15 gives you 19. away. Is that correct? 120? Are you with me?
Yes. 120
So this gives me 169 upon 16 on this side. You get it? So I'm going to do the same here. So I'm going to take away this stuff here because it's kind of in my way. You understand? Right? But then remember, I did my side work. So the LCM here is 4a squared. The LCM is 4a squared. That remains b squared, but here you must multiply by 4a in order for you to get that same LCM. And c times 4a is nothing but minus 4ac. You see it's starting to take shape? So you have got x plus b over 2a all squared. The next thing you do is get rid of that square root. Get rid of the square root. The denominator, when you do this, the denominator should be the same as to what this denominator will be. The square root of 16 must be 4. The square root of 4a squared, if I do it, it should be 2a. The denominator must be exactly the same there. Alright? So I'm going to take away this question, I'm going to come back to it. Or let me just leave it up there, because now, as I said, I'm running out of space there. So when I do that on that side, I'm going to be left with x plus b over 2a is going to be, because I'm taking away the square. When you take away the square, you have to take the square root. And the square root can be positive as well as a negative value. And that is b squared minus 4ac upon 4a squared. The problem of this 4a squared, this is b squared minus 4ac over 4a squared, which leaves you with that because it's a minus, and this one will just remain like that, but this one becomes 2a, because the square root of 4 is 2, and the square root of a squared is a. The square root and the square, they cancel each other. So this is what's going to be left eventually now. So I'm going to write it as x plus b over 2a equals to positive negative the square root of b squared minus 4ac upon 2a. The only thing that is left is I have to bring that over. Okay? So from there you can do the same. You will arrive at the same answer. I'm going to continue with that question when I want to do this one. So now it's just this value that must go. Remember I said this denominator and this denominator should be the same. Since that's a positive, the moment I bring it over, it becomes what? But I'm not putting on this side because this is like an operator. We want it always to be like, second. Doesn't really matter. But I'm going to bring this as minus b over 2a plus minus the square root of b squared minus 4ac over 2a. They have the same denominator, so all of them can be written on the same denominator. Leaving you with b minus b plus minus b squared minus 4ac all over 2a, which is the formula to calculate the quadratic equation value. You get it? When I was doing the side work, I'm not doing it in here. When I was completing the square, I'm not doing that 49 over 16 also here. Because it's already in there. You see what I'm saying? And this is already a perfect square trinomial. If you multiply out this perfect square trinomial, you are going to have a 49 over 16 there. So that is why you have to add on the other side also the 49 over 16. That is how you make x the subject formula. Which is what? Good. Now, I'm going to pick this up from here because I want to finish that for a reason if I want to do that second one. So I'm going to take this off. So when you look at that, x plus 7 upon 4 should now equal to the square root of 169 over 69 over 16. But remember, that is the same thing as this, which is nothing but 13 upon 4. That's what it is. So do not go and use decimals. Separate them because, and here's the thing, this part of the quadratic equation is known as the discriminant. If whatever is under that root is a square number, your answers will be positive or negative whole number values or integers or things that stop. But if it's like a number that is not a square, your answer will be something that needs to be rounded. Because if it's an irrational number, like square root of 160, you understand? 160 not being a square. But if it's negative here, the roots don't exist, you don't even have to go further. That is why, before you solve any quadratic equation, it's worthwhile looking at that and find out if that answer is less than 0, if it's negative, the roots don't exist. In graph language, the graph will never cut the x-axis. Okay? That's basically what it means. Right. So when I solve quadratic equations, I do this, and then I take that answer and I put it directly under, and I can find my final answer. But anyway, this becomes x plus 7 upon 4 is equal to plus minus 13 upon 4. So the two solutions will be negative 7 over 4 plus 13 over 4 when it's positive, or x will be negative 7 over 4 minus 13 over 4. Same denominator, you just focus on the numerator there. 13 minus 7, don't worry, I'll wait.
Minus
6 takes a while. Negative 6 divided by 4, don't worry, I'll wait. Which is the same as negative 1.5. Or 13, negative 7 minus 13 is negative 20.
Yes.
Negative 20 divided by 4, so the second variable will be what?
25.
Negative 5. Negative 5. 13 minus 7, it's positive. Ne? Right. These are the two solutions. Do you see that? Now, what I want to bring here, and I want you to look at the answers here. If you take the roots, which are the answers, and you add them, if you take the roots of a quadratic equation and you add them, it should equal to,
Making sense.
I'm going to say root 1 plus root 2 should equal to minus b over a. Whatever your answers are, if you add these two answers together, it should give you the same value as minus b over 2a. So I expect the answer to be minus 7 over 2. So with that knowledge now, I can solve this question. Does that make sense to you? You get it?
Yeah.
So please, you can have a look at the tape. I'm going to put it up later, and then you can teach them people out there. So I'm going to take this off, and I want to focus on this question. Mx squared minus 13x minus 10 is equal to 0. One of the solutions is equal to 5. First, find the value of m. A question like that, you calculate simply by substituting this 5 everywhere for x, because solutions too, look here. If you take this 3.5 and you take this negative 5, for example, and you substitute it into this formula here, you substitute negative 5 here, you're going to get 0 because it's a solution. It's a rule. Even if you take 3 over 2, you should get 0. Those are the roots. When you substitute the roots of a quadratic equation into the function, it should equal to 0. That's how you know that your equation checks out. Do you understand that? But if you have a rounded number, it will not give you 0, something close to 0. Do you understand? So you must be careful for that. So what does that mean? In order for us to calculate the value of m, I simply take that 5 and I substitute it for x into this equation. So that's going to be like m, 5 squared minus 13 times 5 minus 10 is equal to 0. So this is nothing but 25m minus 65 minus 10 is equal to 0. So this is 25m minus 75 is equal to 0. 25m equals 75. M equals to 75 divided by 25. Therefore, m is equal to 3. That's how you find the value of m. Now, they want us to, for the second part, to find the other root. So now that we know what the value of m is, our equation is now 3x squared minus 13x minus 10 is equal to 0. You understand that? But you don't have to go and factorize or use the quadratic equation to solve that, to find the other root. Because I just gave you a scenario here where I said, if you take the root of one and the root of the other, and you find the sum of the roots of a quadratic equation, they should give you the value of minus b over a. Let's try to find out what is our minus b over a here. It is actually equal to negative. Remember, the minus is already there. Over 2 times 3. So I'm supposed to get something like that. A negative times a negative gives you 13, and 2 times 3 is 6. So that means one root, which is equal to 5 plus, I'm going to write here, other root should equal to 13 over 6. Go ahead and subtract 5 from that number. Therefore, 13 over 6 minus 5. So that will be the second answer. What is that second root equal to? Okay, did we not make a mistake somewhere?
We did.
We put a 3x minus here. 13x minus 10 is equal to 5.
A is not 6, A is 3.
My goodness gracious. 2a. Just a. Just
yes,
a.
Yes,
A is what?
3.
So here we have 3. Okay, so now we can get the other root, which is negative. And you'll get the same answer if you were to solve that using the quadratic equation formula or factorizing. In this case, you will factorize. Why? Because the discriminant is equal to a perfect square. That means if you do b squared minus 4ac, you're going to get a positive square. Okay? As in fact, this is ordinary level. It's nice to know. Right. Bradley, quickly clean here. I want to do, before I start with the new stuff, I want to do the advanced level of question 6. You see, that's powerful stuff if you're dealing with quadratic equations. You have got that calculator, you've got this knowledge, you have got everything to your disposal. You have to ace. You don't have to work hard. You know, there's actually more to quadratic equation. In fact, there's a whole book written about the nice things about quadratic equation. From that formula, or from standard form, you can determine so many things. Do you see that? So if you know the basics, then you don't have to go and try to remember the quadratic equation formula, which is something
Just,
but the AS level students are given a formula sheet where they are given the quadratic equation formula. It's not necessary. Because the A level student should not have to start with the quadratic equation formula. They're equally annoyed actually because we have been dealing with that formula since grade 10. Is it not so? This is 3 years. We are still telling you are struggling with that formula. And the only way to remember that formula is to make X the subject of the formula. It's explained a bit different in your books, but I'm trying to simplify it so that you can get it and much easier. Okay? That is why this is a beautiful subject. Anyway, the last question on this series, before I start with the functions, is on page 151. So what you have there is, I think you have a circle, then you have a triangle, then you have this part is shaded. That is always O. This is Q and T, and this is P. Now I'm just going to add the things they're giving me. They're saying this is R, this is alpha, What else did they give me? They also say that this is a tangent, and a tangent to radius, I hope you still remember, creates a right angle. A tangent to a radius creates a right angle. Are we together so far? The question says, express what is it? The perimeter of where? Of the shaded region. In terms of the shaded region PQT, this, right? In terms of R and alpha, that angle alpha. Now, this part was very important, so you can realize that the line touching a circle and meeting with the diameter or the radius is always going to make 90 degrees. The reason for that is because I want that right angle triangle. Now, what we're looking for, what this question is saying, find this distance. Are you with me? Find this distance and find that distance and add that. Right, let us find the arc first. So I'm going to find PQ. And in order to find PQ, you will have to use this particular formula. Right? But our angle here is alpha. Does that make sense? Right? I am going to find PT. Now there are two ways you can do that. You have an angle here. You have a distance here. Actually, there's only one way you can do this. So what we have essentially is we have a right angle triangle with our missing angle here, and the PT that is here, and a distance R there. So you can find PT by using your trig ratio. Opposite over adjacent is the tangent ratio. So you can find PT by saying the tangent of alpha should equal to PT over R. Opposite over adjacent. Does that make sense? Then you cross multiply, you get PT to be alone. So PT will be R tangent of alpha. Is that clear? So let me just go ahead and write down what I have. I have PT, which is R tangent of alpha. I also have alpha R here. Does that make sense to you? So the only thing that is missing is QT. But I also know that this is the radius from the center to here, and that O to Q is also going to be the same distance. Therefore, O to Q is R. Do you agree with me? Right, so to find QT, I'll have to find OT and subtract R from it. Do you understand that? So I must find the distance O to T. So I'm going to use the same triangle here. Right, I have this distance already, R tangent of alpha. But I'm not going to use Pythagoras. You can go ahead and use Pythagoras if you want to find this distance. I'm going to use what I already have. I have this, I have that, and I'm looking for that distance. So the way you find this distance, you can use, in terms of this angle, you use the sine. Opposite over hypotenuse. I hope you still remember. The sine is opposite over the hypotenuse. So, in order for me to find this distance, I must say the sine of alpha is equal to whatever is opposite, which I actually know whatever is opposite if I use that. It's R tangent of alpha over what? Over the hypotenuse. But maybe I don't want that tangent also in my answer. I'm going to take that tangent. So I'm going to use the cosine. You understand? So I don't have to deal with that. Remember I said initially I don't want to work with this that I've calculated. Alright? So initially Let's suppose I don't want that. Let me say I take my triangle to be the way it was. So let me not work with things where sine and tangent are also involved. So I'm going to say that to find this distance here, I'm going to use the cos sine, which is adjacent upon the hypotenuse, right? So the cos of alpha is equal to opposite, which is pt, over the hypotenuse. Right, what's this? They are sleeping there. R over what? Over OT. Then OT will be R times the cos of alpha. Does that make sense to you? Do you understand that? So if I have my whole OT,
Excuse me, sir. It's a bond. It's supposed to be a bond.
it's supposed to be what?
It's a bond now. It's actually cos.
The other way around, right? R divided by what? Cos. Suppose I was using we can work with this, it's not a big deal. So that's what OT is. So that's the whole distance from here to there.
Subtract alpha.
So I'm gonna find my QT by subtracting the R from that distance.
So you say that.
So QT, always write this because it's helpful, is equal to OT minus, what is it? OQ, am I right? You understand that? And we know that OT is equal to R cos of alpha minus R. I could also have used Pythagoras. If I use Pythagoras, I might get a different answer, but it's the same thing. So there must be two solutions to this. So, my perimeter is going to be PT plus PQ plus QT. QT. PT, what is our PT? R tangent alpha. What is our PQ? It's on the board. Alpha R. What is our QT?
The one below.
Can I put this one in front? Then you get an idea?
Then it's minus.
But it's fine, it doesn't matter. R cos alpha minus R.
Exactly.
O.
Is that the answer?
What else can you do there? O.
Comment.
There's another way of finding it. If I was to use Pythagoras, remember what I said PT was? PT was R tangent of alpha. So if someone wants to find OT using this right angle triangle, yes? Then OT, now the root stuff is coming in.
Exactly. Square root of what?
OT squared will equal to R squared plus R 10 alpha squared. Are you with me so far? I can actually separate that stuff if I was to use Pythagoras. No? Suppose I didn't like the way I was using the ratio there, the cosine, but I want to use Pythagoras to find that distance, this long distance, because there are two ways you can do that. You can, because we've got two sides now, you can find the third side by using Pythagoras theorem. Right, so before I take the square root, I'm just gonna do something here. If I, please don't get confused. So it's R squared plus R squared 10 square alpha. Are you with me? It's the same thing. So OT then should be calculated by taking the good. So OT equals square root of R squared plus R squared 10 square alpha. So if that is OT, then how do we find, we subtract R? So another way for this answer would be, maybe I should also write that down. How to find QT, this one. So we have got two ways of finding QT. QT can also be calculated using this. This is the whole long distance. That is going to be, what is that, OT minus OQ. Is it divided? Something similar there. Our OT happens to be there. Square root R squared plus R squared times square alpha minus R. So that comes now in the place of this. You follow? So my answer could also have been R tan alpha. But now my PQ or QT, no, let's just bring this one down, plus alpha. Then this is going to be that distance minus R. That means being R squared plus R squared tan square alpha.
Okay, see.
So you have two solutions.
What if you use sign?
Yeah, well, now we have a side in there.
So it's also another way.
Yeah. Something will go cancel it on because the side here is going to be this over that. Do you understand? Right. So this is just what one. Yes. Possibilities there. Three solutions. Using the sine, using the cosine, using the Pythagoras theorem. In order to calculate the hypotenuse of any right angle triangle, you are always going to use the sine ratio or the cosine ratio. So not just one, but both can be used to find the hypotenuse with the given information. Because I told you in the beginning, right, the cosine and the sine are co-functions. That dependability is there. And you will see the similarity between the graphs when we now sketch the graphs.
So the third answer we can go.
Yeah, if you can go ahead, if you would like to work further, go work further. Okay, so this is the reason why they give you these things towards the end. But what you should have realized is that you are using all the knowledge that you know so far, of trigonometry, especially right angle triangles, and using this and writing that in terms of that, it builds capacity. You understand? And if you're able to do that, then you are on the right path. Is that fine? Is that fine? Cut. So now we're actually going to start the function.
Oh.